In this section, we're going to talk about the definite integral. If you recall, in the last section, we dealt with the indefinite integral, which meant we were finding the class of antiderivatives. Well, the definite integral means something very different, although we'll see later that it's connected. The big idea here is that the definite integral is going to calculate what's known as signed area. What is signed area? Well, signed area means that when I have shaded an area above the x-axis, we're going to count that as positive. And when I shade an area below the x-axis, we're going to count that as negative. In usual fashion, what we're going to be looking at is an area between the function or some function and the x-axis. In this example, our function is a straight line, or at least our function creates a straight line. If you do the mathematics on this, the function is f of x equals 1/2 x. This is a line with slope 1/2. If I want to find the signed area, the first thing we have to notice is that the entire shaded region is above the x-axis. That means this entire shaded region is going to be counted as positive. Using geometry, we can simply see that this is a triangle. We should all know the area of a triangle, 1/2 base times height. The base of this triangle goes from 0 to 6. So the base is 6 units long, and the height of the triangle, so base is 6 units long, the height goes from 0 to 3 in terms of y values. So the height is 3. Again, area is 1/2 times base times height. That means this signed area is going to be 9. Let's lay that out just so that we have a reference. Area of a triangle is 1/2 base times height. This is a right triangle. So when we look at the base, we're looking from 0 all the way up to 6. So the base is 6, and the height is from, well, 0 on the y-axis up to 3 on the y-axis. So from 0 to 3. So my area is 1/2 times 6 times 3, which, like I said, is an area of 9. So the signed area of this shaded region is a positive 9. Now that we've seen that, we can think about what the signed area for other shapes is. Let's take a line with slope negative 1/2 that goes through the point 0, 2. If you wanted an equation for this line, it would be y equals negative 1/2 x plus 2. I want to find the signed area between this line and the x-axis. Notice that for some of the time, the line is going to be above the x-axis, and for some of the time, the line is going to be below the x-axis. That means this area that's shaded above the x-axis is going to count as a positive, and this area below the x-axis is going to count as a negative. Both of these shapes are triangular. I am going to do them separate. So I'm going to say the total area of the first triangle is 1/2 base times height. When I say first, I mean the leftmost triangle. In the leftmost triangle, the base is 4 units and the height is 2 units. That means I take 1/2 times 4 times 2. When you calculate that, that means the area of the first triangle is 4 units. And again, by first, I mean the leftmost triangle. The second triangle has area of 1/2 base times height as well. But in this case, the base goes from 4 to 6. So the base is length 2. And the height goes from essentially 0, y value of 0, to a y value of -1. So the height is, well, I call it +1 right now. You can see how the signed area comes into play in getting a negative, but I digress. So the second triangle has area of 1. Once again, the first triangle is above the x-axis. The second triangle is below the x-axis. If I want to find the signed area, what I would do is I would say the total signed area is equal to a +4 plus a -1. So the signed area would be 3. This one counts as positive. This one counts as negative. Signed area in our case is equal to 3. Again, this is total signed area. And that's how the signed area works. I would like you to push pause on the video and find the signed area for the shaded region in this picture. Again, push pause on the video, try it, and then I will come back and solve the problem in the next video.